Hello, this video is going to show how we can achieve functional safety using the Eclipse IDE and a Linux target. Now I'm running on Windows at the moment and I have my Eclipse IDE. This is the latest version, and inside there I've installed the SysProgs GNU Toolchain for the Raspberry Pi. So connected to my laptop, of course, I have a Raspberry Pi. This is the latest Pi 4. And on there I've installed my Raspberry Pi OS, and in order to be able to communicate to the target I'm using PuTTY. Now this is the Eclipse IDE, and inside here I have a number of different projects, and let's take a look at this one here. So this is a C++ example of basically a static linked list and a dynamic linked list, and in order to be able to execute it I've got my main here that's basically iterating over this code a number of times and then basically calling various functions. So what I'd like to be able to do is, first of all, well, let's take a look at this code and see, is it compliant to a standard such as the MISRA C++? And I'd also like to be able to look at the quality of this code and find out, well, how complex are these functions? And then I'd like to be able to execute this code. And as the code executes, I'd like to be able to find out, well, how much of this code have we actually exercised? And then finally, I'd like to be able to unit test one of these files in order to ensure we've got 100% structural coverage. So first of all, let's check we can build the code. So let's go here and do a clean. And now we'll do a build. And we can see that it's cross-compiling and it's using the compiler here. Right, so now what I want to be able to do is I want to be able to analyze this code. And the simplest way to do that is go to the LDRA launcher, and inside here I'm going to run the build import. So the build import, I've pointed to the same folder where I have my build.bat, and I'm going to run exactly the same build as we did inside Eclipse. So here we can see it's calling the same compiler. And now we've analyzed the results and we can see, well, we have an executable, we have a number of source files, we have some include paths, and we also have some preprocessor symbols. So we have everything we need in order to be able to start to analyze this code. And I can do that simply by clicking on this button here. Well, to save time, I've already done that. And here we can see the code that's been analyzed. Well, let's go first of all and let's take a look and see, is this code compliant to MISRA C++ 2008? Well, it's not. We can see we have a number of violations. Here, for instance, we have class data is not explicitly private. Well, I've got two cases where this occurs. Let's double click and see where that is. So there we can see, yes, these are public. So that's very easy to fix. I can simply put in a private or protected declaration here. Okay, well, what about the quality of this code? Let's take a look at maybe a system call graph. And the system call graph is going to show us all the functions. We can see how they're interconnected. If I wanted, I can actually take a view where I can see the names. And let's take a look at maybe a number of different metrics. So the metrics giving us an idea of testability. We've got things like the fan out, fan in, procedure exit points. What about metrics that give us an idea of maintainability? Well, this is where we're looking at things like the cyclomatic complexity. And I can sort and find the most complex function, that is the main. Well, let's take a look at the next one here, remove last. Let's view that as a flow graph. So this has got a cyclomatic complexity of 4, which effectively means there's 1, 2, 3, 4 paths through the code. So if I click on a particular block of code here, we can see the corresponding block over there. What about this block? If I click on it, we can see it corresponds to this block over here. What about this branch? Well, that's the branch from here back to there. All right, so now let's go and execute this code. So to do that, we're going to perform what we call the dynamic analysis, and that's where we're going to instrument the source code. We're then going to build it, execute it, and finally analyze the results. So first of all, we can see this is instrumenting the source code. It's now building it using the compiler. It's now executed on the target using PuTTY. We got the results back. We've analyzed those results, And now let's take a look and see, well, what coverage did we obtain? So once again, let's go to the system call graph. And this time we can put this into a view that shows us the coverage. And there we're able to see the coverage we've obtained. So if we sort, we can find where we don't have any coverage at all. So it looks like we haven't called the destructors for node or static linked list, but we have called it for the dynamic linked list. What about the dynamic linked list add first? We have 85% statement coverage. Well, let's view that graphically on a flow graph. And there we can see very clearly we have one block of code that's never been executed. It looks like we've never had a free node equal to null. So if I wanted to get coverage for this, well, I can use the unit testing tool and ensure that I execute this code with free node equal to null. So let's go and unit test this file. So I'm going to go and start tbrun, and inside tbrun I'm going to load a sequence of test cases that I've previously created. So let's find the one for the dynamic linked list. So here we have one for the dynamic linked list. Let's open this, and there we can see we have 9 test cases, and some of these I'm repeating a certain number of times. Well, that's because my dynamic linked list has 16 nodes, and so I want to run it 17 times. So the first 16 times it should do what it's supposed to do, and the 17th time it should then be full, and it should then execute a different bit of code. And finally we can see we're calling the destructor. Over here we're going to be able to see we have a list of the inputs and expected outputs. So let's go and execute this and see what happens. So I'm just going to ignore that, and now I'm building the code. I've executed it on the target. We've got the results back. We can see the tests have all passed, which means that with these inputs we've got the expected outputs we're showing here. Now let's take a look at the coverage, and we can see for the dynamic linked list we now have 100% statement coverage and 100% branch decision coverage. Okay, so hopefully that's given you an idea of how we can work with Eclipse and a Linux target. And if you'd like more information, then please don't hesitate to contact us at LDRA. Thank you.